Hello, Algebra 2 Part 1. This is the second day of 564, so more factoring things completely. So what you have to do today, your homework assignment for tonight, is similar to what you had last night for the first day of 564, except tonight it's matching. So when you go to submit your answers, you're just going to be submitting the capital letter answer of whatever you think the factored version is. So the nice thing about this, to kind of help you along, there's 18 problems and every letter is used only once and every problem has a match. Okay, so that kind of gives you some hints. So what I'm going to do now is I'm going to run through some of the more difficult examples to kind of help you along, get the ball rolling. So I'll start at the end of the worksheet and I'll start with number 18. Okay, so what we have here is 3b to the n plus 2 plus 4b to the n plus 1 minus 4b to the n. Okay, so something with, so we've got b's raised to exponents that include n. So our GCF is going to be a b, and it's going to be a b to the lowest exponent we have, which is b to the n. So we'll pull that out. Okay, the first thing you always want to do when you factor anything is look for a GCF. So we've got a GCF of b to the n, and so if we pull that out, what we're doing is we're dividing every single term by b to the n. So that's what you can kind of picture in your head, and I'll put this in here in a different color, right? If you picture everything being divided by b to the n, okay? Well, when you divide things that have the same base, their exponents you can subtract from their exponents. So for this first division problem, we would have a 3, and then if we divide these b's, well, if you do n plus 2 minus n, the n's just disappear, and you're left with b squared. And then for this next one, we'll have a 4, and then you've got b to the n plus 1 divided by b to the n. So then, you know, n plus 1 minus n, those n's would cancel, and you just have b to the 1, right? And if your exponent is 1, you don't have to write it. And then if you do b to the n divided by b to the n, those disappear, and then it's minus 4. Now, so this, you might be able to factor this with first and last. I'm not quite sure. So yeah, let's try this with first and last. Let's say first is 3, last is negative 4, and then in the middle we have 4. So let's try 3 and 1, and we'll do something with 2 and 2, and we'll make this 2 negative. So if we cross multiply, 3 times 2 is 6, 1 times a negative 2 is a negative 2. If we add those up, negative 2 plus 6 does give us a positive 4. Okay, so 3 and negative 2 are a pair, and those will go in a set of parentheses, and that'll look like 3b minus 2. And then 1 and 2 are a pair, and that goes in a set of parentheses, and that looks like b plus 2. And then we can't forget that we have our GCF of b to the n, and we pull that down, and that's our answer here, right? So then you would go and you would look at the other side of the worksheet that you would have, and you would see that this is option E. Okay, so then look, you already have number 18 done. It's E, and you can eliminate that. So let's do another one that's kind of challenging. Well, 17 is another one that has n's in it, so we can do that one together. Okay, so for 17, we have 2x to the n plus 2 minus 7x to the n plus 1 plus 3x to the n. Alright, so everything contains an x, and all of our exponents have at least n. So my GCF is going to be x to the n, right? So then, again, you kind of want to picture yourself dividing everything by x to the n. Okay, so if we divide every term by x to the n, that'll leave us with 2x squared minus 7x to the 1 plus 3. Right? Now this, whoops, and this should be x squared. Yeah. Now this might be something that we could factor with first and last. So first is 2, last is 3, and then in the middle we have negative 7. So let's try 1 and 2, and negative 3 and negative 1. So we cross multiply. 1 times negative 1 is negative 1. 2 times negative 3 is negative 6. If we add that up, we get negative 7. Okay? So 1 and negative 3 are a pair, and 2 and negative 1 are a pair. So those are going to be in a set of parentheses. We're going to have x minus 3, and then 2 and negative 1 go together, and that gives us 2x minus 1. And then we can bring down this x to the n, and so this is your answer here. X to the n times x minus 3 times 2x minus 1. And so if we look at this, this is option C, right? So then you can cross off that one from your list. Okay, let's see, 16, we also have another problem with n's. We can take a look at that one. For number 16, we have x to the 2n plus 1 plus 2x to the n plus 1 plus x. Okay, so we have a GCF of x. So everything is going to get divided by x. So that'll leave us with x to the 2n plus 2x to the n plus 1. Right? So what you can kind of picture in your head, everything was divided by x. Right? Because that's our GCF. Now, this right here, this is something that we can factor with first and last. So first is 1, last is 1, and then in the middle we have 2. So I'm going to have 1 and 1, another 1 and 1, cross multiply, we get 1, add those up, and we get 2. So I bring down my GCF, we hold on to that, and then the 1 and 1 go together, and that'll give us x to the n plus 1, and then this 1 and 1 go together, and that gives us another x to the n plus 1. So that is your answer here. And another way that you could write this is you could have the x out in front, and because you have two of these and they're exactly the same, that's the same thing as x to the n plus 1, the whole thing squared. Alright, so which option is this? This is going to be option G. Okay, so 16 is G. So, let's see, we've done a bunch of ones with n's. Let's take a look. Okay, 14 is something different. 14 has 4 terms in it, and that's going to be grouping. So let's try that one. So for 14, we have x to the 6th, y cubed, plus x cubed, minus x cubed, y cubed, minus 1. Okay, so we've got grouping. So I'm going to throw some parentheses in. X to the 6th, y cubed, plus x cubed, and then minus x cubed, y cubed, minus 1. Now remember, when you're factoring things with grouping, where you put in your own parentheses, if you have a minus between the two sets of parentheses, you have to flip this sign here. So this sign now becomes a positive. Okay? So now we can go ahead and find the GCF in each set of parentheses. So the GCF in this set of parentheses is going to be x cubed. And if I pull that out, well, x to the 6th divided by x cubed, that'll give me x cubed, and then I still have that y cubed. And then this is just plus 1, okay? And then over here, I'll have x cubed, y cubed, plus 1, okay? Now, there's no GCF in this, but I do have a number in front that's hiding. It's a 1, okay? So, now if we think about this, if you think about this as one chunk and this as another chunk, what's common to both chunks is x cubed, y cubed, plus 1, and we can pull that out. And what you have left is x cubed minus 1, okay? Now, both of these can be factored further. Both of these are perfect cubes, okay? So, let's see. X cubed, y cubed, plus 1. Well, we're going to need some more space for this. I'm going to get a new sheet of paper, and I'm going to copy this down on the top of this, right? So what we want to factor further is what we just got. X cubed, y cubed, plus 1, and then x cubed minus 1. Okay, so we're going to factor both of those further, both of these are perfect cubes. Okay, so if I start off with this first one, I will take my cube roots, and that'll give me x, y, and 1. And then if I multiply those, that just gives me x, y, right? So in this step, I took my cube roots, and then I multiplied, and then I'm going to square. And so that'll give me x squared, y squared, and 1. Okay, so now all of these pieces, these 5 pieces, 1, 2, 3, 4, 5, I'm going to put in parentheses. So remember, I have a small set of parentheses and then a larger set of parentheses. And the order of the signs, we're going to go same, opposite, plus, SOP. So my first sign is the same as what's in this set of parentheses, so that'll be a plus. The next sign is the opposite, so that'll be minus, and then the last one is always plus. So in your first set of parentheses, we'll have our cube roots. So this will be x, y, plus 1. And then what you got from multiplying goes in the middle, right here, and then your squares go on either end. Okay, so we did the first half. Now, the second half, x cubed minus 1. So same process. We take our cube roots. So the cube root of x cubed is x, the cube root of 1 is 1. And then we take those and we multiply them and we get x. And then we take those and we square them and we get x squared and 1. Now we set up our parentheses. So we have a small set and then we have a larger set. So my small set, okay, the order of the signs goes same, opposite, same, opposite, plus. So this one starts with a minus, so that's my same. Opposite is plus, and you always end with a plus. So your cube roots, x and 1, go in your first small set of parentheses, so that'll be x minus 1. Okay, what you got from multiplying goes in the middle down here, and then what you got from squaring, x squared and 1, goes on either end. So then this right here is your whole answer. Okay, so it's very long, it took us some time, but nothing too difficult. You just have to be methodical about it and neat with your work. And so then if we go ahead and look at our answer options, this is going to be, this is a long one, isn't it? This is going to be N. Yes. Okay, so number 14, this was number 14, is N. So there you go. We got that one done for you, and you can eliminate that one. So let's see what else looks kind of tricky on this. Let's see. We did one with 4 terms. Do we have any with 2 terms that we could do? Yeah, let's go ahead and take a look at number 2. So for number 2, I have 16a to the 4th minus 2a. So the first thing, whenever you're factoring anything, is you always want to try to find a GCF. Okay, so GCF here, well, both of these are even numbers, so they're both divisible by 2, and everything contains an a, so we'll pull out an a. So if we pull that out, we're left with 8a cubed minus 1. Now, you have to ask yourself, can I factor the 8a cubed minus 1 any further? And yes, you can. This is the difference of 2 perfect cubes, okay? So, the cube root of 8a cubed is 2a. The cube root of 1 is 1, right? So, those were our cube roots. And then you take the 2a and the 1, and you multiply them, and you get 2a. And then you square them, and that gives us 4a squared and 1. And now we can set those up in our parentheses. So we have a small set of parentheses and then the larger set of parentheses. And the order of our signs goes same, opposite, plus, right? So we start off with a minus, so that'll be a minus. Opposite of that is plus, and we need another plus. So your cube roots, 2a and 1, go in your first set of parentheses, so that'll be 2a minus 1. What you got from multiplying goes in the middle, and then what you got from squaring goes on either end. And then you drop down your 2a. Okay, so our answer, let's see if we can find this. Yep, and this is going to be option P. Okay, so number 2 is option P. Let's see if we have something else. that we can try. Let's go ahead and take a look at number 12. Let's see. So for 12, we have 4x squared y squared minus 4x squared minus 9y squared plus 9. Okay, so 4 terms in here, so this is going to be grouping. So we can go ahead and throw in our own parentheses. So let's see, I'll have parentheses around the first 2 terms, and then I'll have parentheses around the last 2 terms. And when you put your own parentheses in, if you have a minus between them, you have to flip the second sign. So that means that this plus sign is going to become a minus. Okay? And now we can go ahead and find the GCF in each set of parentheses. So the GCF in my first set is going to be 4x squared. And if I pull that out, I'll be left with a y squared minus 1. And then the GCF in my second set of parentheses is going to be a 9. And if I pull that out, I'll be left with a y squared minus 1. So here's your first chunk, here's your second chunk. What's common to both is y squared minus 1, and then if you pull that out, what you have left is 4x squared minus 9. Now both sets of parentheses, both of these is the difference of 2 perfect squares, and you can factor these further. So y squared minus 1 is y plus 1 times y minus 1. I just got that by taking the square root of each term. And we can go through the same process on 4x squared minus 9. That's going to be 2x plus 3, and then 2x minus 3, right? And now at this point, we can't factor that any further. So for number 12, if we find that answer, that's going to be option Q. Okay, so we knocked off that one. Alright, so we did 6 problems. We knocked off a third of this. So hopefully you can figure out the rest of this on your own and use process of elimination to find the answers to this factoring.